Now let's focus our attention into costing techniques for planned capital cost estimations. Remember that in economics and optimization, an important part that you do right after you design your chemical plan is to calculate the fixed capital investment or the total capital investment. And this can apply for a chemical plant or a chemical product manufacturing facility. And basically, it is a one-time expense for the design, construction, and startup of a new plant or a revamp of an existing plant. Remember, you can start a company from scratch, or you can just add something right to a complex that is already in place in the plant facility, or a smaller project or something like that. You can also upgrade the capacity of the plant, requiring that you need to double the amount of equipment or change some of the original design of the chemical plant. So before I go through the different costing techniques, I need you to think about the boundaries of a chemical plant, because based on that boundary will be the estimations and the type of cost that we do. So there is something called the battery limit of the chemical plant, and the battery limit is basically the process that you design in HYSYS, right? That you're using that software right now. So that battery limit includes the process, right? Anything, all the unit operations are required. Notice that outside that boundary are the different interactions with that battery limit, which is the process that you design. You may have the waste treatment that is outside, that is not considered a part of your design. You have the solid disposal. You have the storage handling, right? You have the space where those storage handling is located. You also have utilities, if you see them on the top, right? You have multiple utilities that can be added to support that process that you design. You also have different areas, right, where people that work in your company needs to be able to do their work, right? You may have the sales department, the shipping area, you have the offices, the admin offices, you may have cafeteria, maintenance shops, a laboratory, a library, maybe an R&D office, maybe the engineering area. You may have a parking lot, right? You may have a gym if you need your employees to be happy and being able to do exercise during the day. You also see on the left side, you may need access to railroads, right, to be able to send your large amount of raw materials or shipment, right, of the final product. So depending, right, on how much you need to cost out, you may say that your plan, right, that battery limit, that process will be part of what we call an integrated complex, which is just an addition to an existing plan. That means that a plan already has the ancillary facilities to support the process that you're designing. Or you may be designing a grassroots plan, which is just a brand new space. So you can imagine that the cost is completely different, right? Because you need to, in a grassroots plan, you need to invest on the ancillary facilities, setting up the area, installing the utility setups, right? You may need to add the parking spot, the shipping area, all of those different ancillary spaces may need to be created in a grassroots plan. So when you do a design like this, you need to really understand what are the boundaries of your plan, right? Because the economic analysis that you will do depends on that. So depending, right, again, if you have already an integrated, if your plan design will be part of the integrated complex or a grassroots plan, you may have different things that can be included in the fixed capital investment calculations. For example, you have what we call the total bare module investment, and that is basically concerned about how much is the cost of installing and setting an equipment in the process within the battery limits, which is this area here in the process. You also may have cost of site preparation, cost of service facilities, allocated costs for utility plants and related facilities, total of direct permanent investments, cost of contingencies and contractor fees, and we're going to go through all of this throughout this lecture. You also have the total depreciated capital, cost of land, cost of royalty, cost of plant startup, the total permanent capital investment, and the working capital. And we're going to go through all of this throughout the different steps, right, that we're going to partake when we are trying to calculate the profitability of a chemical plant. I just wanted to give you this idea because not all of it may be included in your analysis. So there are different techniques that you can use to calculate this fixed capital investment. Your book suggests a method, right, that you can use. I'm going to be presenting one that is based on Turton's book. And the reason why we're using that method will be because we're going to be using a software called Capcost that is going to help you to generate what we call cash flow diagrams. And those cash flow diagrams can help us to calculate profitability. So we're going to be integrating two different sources, but I think the most important thing is that the techniques that we typically use are based on the purchasing cost of equipment. So what I'm talking about is the equipment purchase price, right, is the base of our calculation. All of these techniques use that as our base of calculation, and basically is the FOB, which is the free on board price. So which is just the price when it comes from the manufacturer of that company, right? We go and pick it up, and that is the price, right, of the equipment that we are going to be installing in the plant. Notice on the right side, we have an example of how the different costs, if we document, right, costs associated with heat exchangers, we can then collect data, right, from multiple years, multiple type of equipment, multiple sizes, right, and we can find that basically once we know the purchasing cost, the CP, right, we can see that the other costs associated, they're just fractions of a factor, right? They're a factor of the actual purchasing cost. So the bigger the equipment, right, the more impact on the other things, right, that you need to include it in the installation of that equipment. Things that you can things that you can include are field materials used for installation, the total direct field materials that you need, right, which is going to be the addition of all of those numbers, right? You can also have the direct field labor for installation. That includes the material erection, the equipment setting. You can have the indirect module expenses like taxes, construction's overhead, constructor engineering expenses, total indirect expenses, and all of this information kind of like add up to what we call, right, the bare module cost calculation. Once again, this is just an example, so from your book, right, where you can see that the CP is just a factor of or a fraction, right, of the CP. It's just a factor, right? We have a factor associated to that particular expense that we're analyzing. We're not going to use these equations, but I'm going to present you some other equations that we're going to be using based on another reference. In the future, you just need to make sure that you're in accordance, that you understand what are the techniques that your company uses. Once again, these are big assumptions. The information that we get from the equipment, they typically end up being dependent on the type of manufacturer that you buy. It depends on the type of equipment. Not all of the heat exchangers are the same. So you may need to do some assumptions. You can also refer to the Paris, that it has also some factors that you can use. The important thing is that you document your assumptions and you're clear and in specifying before you do an analysis like this, that these are the techniques that you're using, okay? So the estimation of equipment costs basically it helps us to estimate the capital cost of a chemical plant, and the cost associated with major plant equipment must be known to be able to do this. So this is why in this class you are designing a chemical plant that I'm helping you to kind of put together with information about it, and we are going to be using that design that you do, and we're going to be costing out and analyzing it. So what we need in order to do an estimate of equipment cost is, of course, we need the PFD, and the process flow diagram must include both materials and energy balances, which each major piece of equipment identified. The materials of constructions must be selected. The materials of constructions may not be provided by the software. You may need to make some decisions about it. So, and also the size capacity roughly estimated from conditions on the process flow diagram. So this is the factors that we're going to be using in our class. Okay, again, this is based on Turton's book. This is the cost calculations, and this is just an overview. We're going to be focusing on the first one, which is the bare module cost. So the bare module cost is the direct project expenses, indirect project expenses, freight, insurance, and taxes, which is what I told you right before on that table. So it's just considering, right, what do you need to install an equipment? So bare module is per equipment. Notice that the bare module cost can be calculated using as basically a factor, right? A factor of the purchase cost of the process equipment. So if we know the purchase cost, then we can calculate the factor, what we're going to call now the bare module factor, and that bare module factor will depend on the type of equipment, as I mentioned before, right? For heat exchangers, it's going to be a number. For conveyors, for any, you name it, right? Reactors, vessels, distillation towers, the bare module cost will be changing, and the way it changes is not only from the purchasing cost, but also by that factor. And we will see that factor not only depends on the type of equipment, but also on the process conditions. Then once we calculate that, we have to decide, right, are we going to have this plant that we're building, is it part of a complex facility that we already have in place, or is it something that we need to design from scratch, including the ancillary facilities? So depending on the answer of that, we're going to need to calculate the total module cost or the grassroots cost. So the total module cost, as you can see, is just the addition of all of the bare module cost of the equipments, right, that we have in our process flow diagram. That will be multiplied by a factor, and that factor is 1.18, which is the total module factor. And if that's it, right? We don't need to think about building the facilities, the ancillary facilities to the plant, like the gym and the sales and the storage tanks and all that, right? So if we don't need to think about that space, then we don't need to calculate the grassroots module. But in case you do, right, notice that once that you calculate the total bare module cost, what we're going to do is use it to calculate the grassroots module cost. I want you to notice that there's a knot here, CP knot, right? And you have a bare module knot here. And I'm going to explain that as soon as we get to that part, that the knot means that we're considering the equipment at base conditions. At base conditions is basically using a material of construction of carbon steel and at a pressure of 1 atmosphere. If you increase temperature, right, a high temperature, you need to change the materials of construction, so it's no longer going to be using carbon steel. If you increase the pressure, right, or decrease it in a vacuum, then you're no longer operating at base conditions. So what we have here, right, is that you can calculate the total module cost at base conditions or not base conditions. But in the grassroots module cost is the CTM, which is considering the non-base conditions of the process, but you add, right, a factor that is related to the size of the plant and not necessarily any deviation or cost penalty due to the differences, right, in the process conditions. Once again, I'm going to get through all of this, but I wanted to point out that. So now what we're going to do is focus on doing this calculation. So there's going to be a lot of parts for this video, but I hope that you enjoy it. It's really fun to do it.